Hello, my name is Will, and this is my report for Physics 2 Lab 2. First, I will do a quick overview of the lab and results. This lab was an extension of Lab 1, in which we charged two pieces of scotch tape and floated one on top of another. We used our knowledge of force of gravity and net force to calculate the charge acting on the particles. We then proceeded to model this interaction in GlowScript as 2-point charges acting on one another. In this lab, we expanded on our glow script by modeling two lines of point charges acting on one another instead of two singular point charges. After I completed this lab, I found that there was electric force of 0.17 times 10 to the negative third and a charge of 1.5 times 10 to the negative 8. These values were found when the tape was floating about 0.012 meters above the other. Later in this lab, I'll explain the physics principles behind everything, how the lab was performed, my glow script process, and do some analysis. Firstly, the main physics principles used in this lab were the formula to find electric force. This formula also consists of the electric field formula also present here, but essentially you can multiply the charge by the electric field formula to find the force. Newton's first law was also used in this lab, and this was used to define the gravitational force acting on the upper tape. And essentially, we used this to find charge in lab 1 by knowing they were at equilibrium, so we could solve for charge in lab 1. And then finally, the another important part used in this lab was the superposition principle, which is essentially the idea that an electric field is or a force acting on an object is the sum of its parts. And I'll go into more detail how I use these further in the lab. I'll now go over how the lab was actually performed. So first, I started with the glow script. Um, First I started with the charge that I found in Lab 1 and used that as my predicted charge in GlowScript. And then next I began filling out the GlowScript shell when applicable. One of the most important pieces was identifying the system as the upper tape and the surroundings affecting it. And this would be the lower tape approximately 0.012 meters away and the force of gravity. This GlowScript model was an expansion from that in Lab 1. In Lab 1, we treated the tapes as point charges, while in this one, we treated them as lines of point charges all acting on each other. We used the superposition principle to find first find the electric field, and then secondly, we found the force acting on each piece of tape. From there, we were able to find the net force on the tape, and this is how electric force is typically found when you're trying to find it for an object that isn't necessarily a point charge. You essentially divide it into infinitely small pieces, and then use the superposition principle to find how it is moving in the net force direction. I then adjusted my predicted charge after I completed the GlowScript shell to match the gravitational force. So I adjust my predicted charge to affect the electric force so that it would be at equilibrium. Here's my model and results in GlowScript as well as my code. So the most important parts of my GlowScript were setting up the position of each tape, calculating net electric field using the function from lab 0, finding the net force by using electric field, and then the charge of the tape sections, and then finally correctly assigning the arrows and their scales. All these changes are included in the images of the GlowScript shown on the right. That's all the actual code, and then my model on the left can also be seen here, where you can see that the force of electricity is roughly equal and opposite to that of gravity. You can also see that the arrows on the charges are not all directed straight up in the y-axis. This is because all charges on the bottom tape act on every charge on the top tape. So charges in the center end up canceling each other out because they're affected from both the left and the right, while charges on the ends are only affected on one side in the x direction, so they kind of have a more significant slant. And then the end, because they're equal and opposite on each side, it ends up canceling out, leading to a force straight up in the y direction for electric force. Um, and then finally, I'd like to do some analysis. So firstly, I would like to go over some assumptions I made. First, we assumed air resistance is negligible. This could potentially affect how far the tape would float, but it's likely wouldn't make much of a difference at this small a scale. Another assumption made is that each U-tape had the same charge and that each U-tape held the same charge. Theoretically, this would be true, but realistically, it might not be. And then some questions I was tasked with answering was how would the model change if I conducted it with 2-point charges like the first lab? So previously, I got a value that was considerably smaller when I was using 2-point charges, and this was likely due to the model not being an accurate representation of two pieces of tape. Realistically, two pieces of tape are a collection of atoms in a line, and then this new model for Lab 2 is kind of a more accurate representation of that rather than two single point charges. It's also likely that as n increased the number of atoms in the line, the more accurate the model would be. And then some other potential sources of error could be that we assume charge is equal across all points in the tape and that the charge is stable, and those might not necessarily be true and might affect my results. Thank you for listening.